If you've been scrolling through the news lately, specifically around May 2026, you've almost certainly seen the headlines about the MV Hantavirus cruise ship. An outbreak of a rare, highly fatal disease forced evacuations, kicked off massive international contact tracing, and tragically led to 3 fatalities. The culprit behind all this? Hantavirus. Now, headlines like that, they're basically designed to generate panic. But here's the thing, fear really only thrives when we don't have all the facts. So, in this explainer, we are going to replace that fear with a rock-solid clinical understanding of exactly what this pathogen is, how it operates under the microscope, and how global health agencies are actually handling it.
Okay, let's dive right into this. We need to start with some crucial context straight from the World Health Organization. They explicitly note that, for the vast majority of the global population, the risk is incredibly low. Routine tourism carries practically zero risk of exposure. You're generally not going to catch this virus just by walking down a city street or taking a standard vacation. But, and it's a big but, despite that reassurance, when an infection actually does happen, the sheer severity of this virus absolutely demands our attention.
To really put those high stakes into perspective, just think about this number, up to 50%. That is the staggering mortality rate for severe hantavirus cardiopulmonary syndrome. And yes, that is the specific strain involved in the recent cruise ship outbreak. When this virus takes hold in its most severe form, it is remarkably lethal, no question about it. Which means we really need to understand exactly what we're up against here.
So let's step back from the breaking news for a second. Section 1. 2 Faces of Hantavirus. We're going to look at the foundational medical background of this deeply fascinating family of viruses.
First off, hantavirus is not just one single bug, it's actually an umbrella term. We're talking about a whole group of enveloped, negative-stranded RNA viruses in the Hantavirus order. The name itself is actually a bit of a history lesson. It dates back to the early 1950s during the Korean War. Thousands of soldiers suddenly fell mysteriously ill near the Hantan River. At first, people literally thought it was some kind of new biological weapon before the actual virus was identified. So how does it get around? The primary carriers are rodents, mice, rats, voles. And here's the wild part. These animals are completely asymptomatic. They don't get sick at all, but they constantly shed the virus in their urine, feces, and saliva. As humans, we usually get infected simply by inhaling those aerosolized viral particles when we're, say, sweeping up dust in an infested area.
Now, what's really interesting about this is that different strains of the virus cause 2 entirely distinct clinical nightmares. On one hand, mostly over in Asia and Europe, you've got hemorrhagic fever with renal syndrome, or HFRS. Like the name implies, it aggressively targets the kidneys, and it carries a mortality rate of roughly 1 to 15%. On the flip side, mostly found in the Americas, is hantavirus pulmonary syndrome, or HPS. This one goes straight for the lungs, bringing with it that massive mortality rate of up to 40 or 50%. Both of these involve your microscopic blood vessels becoming dangerously leaky, but the actual battlefield inside your body? Totally different.
And that specific battlefield really comes down to geography and which rodent you're dealing with. In North America, the main culprit for HPS is the Cinnabre virus, carried by the common deer mouse. Over in Asia, it's the Hantan strain from the field mouse. But I want to zero in on the Andes strain, carried by the long-tailed pygmy rice rat down in South America. This is the exceptionally virulent strain that was confirmed on the MV Hantavirus. And get this, it's a massive detail. The Andes strain is the only hantavirus currently known to allow for human-to-human transmission. It's incredibly rare, sure, and usually only happens between people living in very close quarters for prolonged periods, but it is a real game changer.
All right, so we know the vectors. Section 2. How the virus attacks. Let's zoom way into the microscopic level to see the actual violent pathophysiology of this infection once it's inside you.
Here is the exact biological sequence of how HPS unfolds. Step 1. Those infectious particles are inhaled, traveling deep down into the tiny air sacs of your lungs. Step 2. The virus actively invades your vascular endothelial cells, basically the cells lining your blood vessels. It does a sort of molecular handshake, attaching to these receptors called beta-3 integrins that normally regulate how leaky your blood vessels are. But here is the fascinating and honestly terrifying twist. The virus multiplying inside those cells doesn't actually destroy them. Instead, it's step 3. Your own body mounts a massive T-cell immune response. Your immune system inadvertently causes the real damage, which directly leads to step 4. Your blood vessels start leaking fluid heavily and rapidly into your lungs.
So the absolutely crucial point here is that this massive organ failure is largely driven by friendly fire. Your immune system detects the virus, hits the panic button and triggers what's known as a cytokine storm. It basically floods your bloodstream with massive amounts of inflammatory chemicals. This extreme overreaction dramatically increases capillary permeability. Literally, your microscopic blood vessels become highly porous like a sponge, and fluid just rapidly floods into the empty spaces of your lungs.
So, what does this actually feel like for the patient? Well, it's a terrifyingly deceptive timeline. After you're exposed, the virus incubates in total silence for anywhere from 1 to almost 6 weeks. You feel completely fine. Then comes the prodromal phase, a solid 3 to 6 days of really vague, nonspecific symptoms. We're talking high fever, a nasty headache, maybe some backache or nausea. It looks, feels, and acts exactly like a bad case of the flu. But then, boom. As that cytokine storm hits, the patient enters a terrifying 48-hour window of rapid respiratory compromise. The lungs just fill with fluid, causing severe shortness of breath, a sudden, dangerous drop in blood pressure, and potentially total cardiovascular collapse.
Section 3. Diagnosis and supportive care. Once a patient enters that terrifying window, survival basically depends entirely on the medical community's ability to quickly identify it and fight it out in the ICU.
Now, figuring out if it's hantavirus, a super severe flu, or acute respiratory distress syndrome is notoriously tricky. But the very first major red flag for clinicians? Thrombocytopenia. That's an unexpected, sharp drop in blood platelets. If a patient comes in with flu symptoms, but their platelets are tanking, that's often the light bulb moment that moves them from a standard flu diagnosis to suspected hantavirus. Very quickly after that, chest x-rays will show bilateral interstitial edema, fluid visibly pooling in both lungs, and blood tests will start showing all these atypical cells in immunoblast, proving the immune system is in absolute overdrive.
And the sheer level of intense respiratory support these patients need, it really cannot be overstated. Roughly 40% of all hantavirus pulmonary syndrome cases end up requiring mechanical ventilation. Think about that. The lungs literally cannot exchange oxygen anymore because of all the fluid buildup, so the patient has to be intubated just to survive.
And this brilliantly illustrates the insane challenge of critical care medicine. Because right now, there's no cure for hantavirus, no approved antivirals, no vaccines. Treatment is 100% supportive. It relies on this incredibly delicate high-wire act of fluid management. Doctors have to give the patient just enough IV fluid to keep their heart pumping and blood pressure up, but not so much that it worsens the fluid already drowning their lungs. They rely on drugs like dobutamine to help the heart muscle pump. And in the absolute most critical cases, they hook patients up to ECMO machines. These machines completely bypass the lungs, taking the blood out of the body, oxygenating it, and pumping it back in. It is this highly structured, exhaustive supportive care that actually saves lives. All right, Section 4, Prevention and Global Outlook. Let's zoom back out from the intensity of the ICU to look at the real-world implications, public health, and how the story of the MV Hantavirus is actually wrapping up.
When those suspected Andes variant cases first popped up on the Hantavirus, which, by the way, were almost certainly brought on board by passengers who had just been traveling through South America, global health agencies didn't mess around. They acted incredibly fast. 3 suspected patients were immediately evacuated to the Netherlands. Another confirmed case was isolated over in Switzerland. The UK Health Security Agency stepped in to make sure returning British passengers were isolating at home with rigorous testing. And because we know the Andes strain requires that close, prolonged contact to spread from person to person, this aggressive combo of infection control, self-isolation, and contact tracing means the actual risk to the broader public remains exceptionally low.
Let's move on and see how this builds into practical, everyday prevention. Without a vaccine, your ultimate #1 shield against this virus is simple. Avoid the vector. Minimize human-rodent contact completely. If you're heading into a shed, a barn, or a cabin that's been sealed up for a while, air it out. Ventilate the space thoroughly before you go in. Natural UV light from the sun actually does a fantastic job of neutralizing the virus. And please, never ever sweep or vacuum dry rodent droppings. All that does is kick the invisible viral particles straight into the air you breathe. Instead, soak them down with a strong disinfectant first and always wear protective gear. Which brings us to our final thought. This cruise ship outbreak really is a stark reminder that we share this planet with incredibly complex, microscopic ecosystems. Hantavirus might be rare, but it is a potent, undeniable reminder of nature's boundaries. So, as global tourism pushes further and deeper into diverse, untouched habitats, it leaves us with a really important question to chew on. How do we best balance our very human desire to explore the world with the hidden, deeply serious risks of emerging zoonotic diseases?
Understanding the science, instead of just giving into the panic, is absolutely the first step.